Okay, here we're faced with a problem that gives us the population of an endangered animal species in 2 different years. In 2003, they said that there were 150 of these animals remaining, and then in 2004, that number had decreased to only 120. This problem wants us to assume that this trend is going to continue and that this is going to be decreasing exponentially. It wants us to write an exponential function to model this scenario, and then it wants us to use our function to figure out the population of this endangered animal in the year 2014. So the first thing we're going to do to figure out that percent is we're going to take the most recent value that we have and subtract the year before that. So we're going to do 120 minus 150, and then we're going to, we want to know the percentage out of the total that decreased, and the total was 150 to start with. So doing that, you get negative 30, so there's a change of negative 30 over the total original population of 150, and simplifying that, we get negative 1/5, or negative 0.2. So we have a percent decrease of about 20% per year, what that's telling us. Negative 0.2 represents a 20% decrease in the population. So now that we have that, we should be able to go ahead and write our function. So I'm just going to use y equals for this. So I'll say y equals our initial value, which was 150, times 1, since we're decreasing, we'll subtract the 0.2 to the x. And time is our independent variable. I'm just going to use x for writing the function for my independent variable. Simplifying this a bit, I have y equals 150 times 0.8 to the x. So there, I've created the model for that. I'm going to go ahead and erase this work here in the middle. Move my function up so I have more room to continue. So my function that they wanted is y equals 150 times 0.8 to the x. We can see the initial value of 150 of these animals represented there, and we can see that there are, if it's decreasing by 20%, there should be 80% or 0.8 of the population remaining each year for that. Now, the second part of the question wants to know what the population will be in the year 2014. So we need to know what to plug in for this x. And x is standing for the number of years that have elapsed. So from 2003, when we had our initial value of 150, until 2014, 11 years have elapsed. So that's what I need to plug in for x. So I will do y equals 150 times 0.8 to the 11th. And then I'll go to my calculator and I will compute that. 150 times 0.8 to the 11th power. 150 times 0.8 to the 11th power. That's better. Is giving me y is approximately 12.88490,189, like that. So we'll just go ahead and round that off and say approximately 13 years.